Well, this incident occurred on the Mars Polar Lander during an at-low configuration as landed test. As we build more and more spacecraft, and spacecraft become smaller and smaller and more intricate and more complicated, configuration management of all deployed devices becomes extremely important. This particular test was a deployment test. This was a post-landing deployment test that they were going to test the medium gain antenna deployment. As once you land, that's one of the first things you have to do is deploy your communications devices. So during the process of testing the medium gain antenna, part and parcel of this is how you power a spacecraft when you're doing testing. Sometimes you test with electrical ground support equipment powering the spacecraft. Sometimes you like to test end-to-end with your actual spacecraft batteries and spacecraft power. When you're doing spacecraft-powered testing, sometimes, however, you don't have any real control, which you should. Generally, your control is through avionics and how to stop something. So what happened is as they were deploying the medium gain antenna, they did not realize that they had not reconfigured their solar panels into the proper state. So the medium gain antenna then, as it was deploying, contacted the solar array. And because this was onboard power and they did not have a way of stopping it immediately, there was some damage done to the solar arrays. So what this lesson goes to and the risk goes to is it's a fairly high-level risk that when you're doing testing on your flight system, especially at the full-up flight system level testing, you want to make sure that you know where all your deployment is going to take place, the configuration of each of your deployable devices, to the end that you make sure that nothing is going to be contacted. So you want to make sure that as you test, that you're in your proper flight configuration and landed configuration in this case. And this would go to any testing that you do for configuration control, and this would be partly software too, that you know what your software sequences are going to be, what your deployable sequences are going to be, and make sure you go through a complete review, test review prior to make sure that all of your components are in the proper state before you actually start engaging and deploying components. This also goes to testing that you would do at a much smaller level, at a subsystem level. Because even if you have two devices that are deployed, it's as simple as that might sound, you want to make sure that they're configured properly. And configuration control is something we're always considering throughout the process of a flight system, especially for software. But in this case, it was for hardware. It wasn't done appropriately. Something else as a lesson learned from this is that you want to be able to control at any point in time, especially when you're on the ground doing end-to-end testing, you want to be able to control your power. So part of this lessons learned is to make sure that you have some sort of an e-stop or emergency stop button, regardless of what the configuration is, whether you're on ground support power or whether you're on the spacecraft power, that you have some capability of stopping something in an emergency type situation immediately so that you don't do damage. So that was part of this lesson.